Here we have the function x to the power of 7 over x, and we want to find the derivative here. And so this is the same as y equal to x to the 7 over x. And then next, we'll take the natural log of both sides. So we get ln y. And again, the power rule says that the 7 over x, we can place it in front of the ln. And then now we'll do implicit differentiation. With respect to x. And so again, with implicit differentiation, we do the regular derivative, and here the variable is not x, and we have to multiply by the dy dx. So regular derivative ln y is just 1 over y. But here we do a derivative with respect to x, but the variable here is y, and so we have to multiply by dy dx. And then this is we can write this as a quotient, and then we can use the quotient rule right here. So this is the same as 7 ln x, and then this is just x. And this is a quotient, and the variable here is x, and we do a derivative with respect to x, and so we just do the usual derivative. So the quotient rule is the denominator, and then times the derivative of the numerator, and then minus the numerator times the derivative of the denominator, and then divided by the denominator squared. And so that's the quotient rule. And then right here, the derivative of 7 times ln x, it be just 7 times 1 over x. Here the derivative of ln x is 1 over x. And then the derivative of x right here, this is just 1. And then this is 7 times 7 over x, as though we just get 7, and then minus 7 ln x times 1, which is 7 ln x. And in the bottom we have x squared. And then multiply both sides by y, and so we end up with this right here. And now multiply both sides by y. And so we get dy dx is equal, but y is x to the 7 over x, so we get 7x over x to the 7 over x, and then times this. So this is the derivative, so dy dx, that's the same as f prime of x. Here we have the function x plus 1 to the x, and we want to find the derivative. And so again, this is the same as x, y equal to x plus 1 to the x. Now we take the natural log of both sides. So we get ln y, and the power rule says we can place this exponent right here in front of the x. And then now we will do implicit derivative differentiation with respect to x. So we're doing derivative with respect to x, but the variable here is y, so we'll do the regular derivative. Derivative ln y is just 1 over y, but the variable is y, so we have to multiply by dy dx. And then here, this is just x, and we're doing derivative with respect to x, and so we just do the usual derivative. And this is a product, and so we have to use the product rule, so it will be x times the derivative, be the first factor times the derivative of the second factor, and then plus the second factor, and times the derivative of the first factor. The derivative of x is just 1, so this part right here we just get 1. And then right here we want the derivative of ln x plus 1. Recall that the derivative of ln x, so we just have the derivative of ln x, then this is equal to 1 over x. But here we have derivative of ln x plus 1, so we have to use the chain rule. And so this will be 1 over x plus 1, and then times the derivative of x plus 1. But the derivative of x plus 1 is just 1. And so we just get 1 over x plus 1. So this part we just get 1 over x plus 1. And so here we just get x divided by x plus 1, and then this part we just get ln x plus 1. And then now multiply both sides by y. So multiply this side by y, and then multiply this side by y. So we get dy dx, but y is x plus 1 to the x. And then dy dx, that's the same as f prime of x.